So why don't we go ahead and do that here. So I'll select full screen and get started. Okay, let me know when you've started the recording.
I started. You're good to go.
Okay, thank you very much. All right, well, again, welcome everyone to our program tonight for Chapter 21, and thank you all for attending. It's great to have a group of 21 participants. That's strange, isn't it? Chapter 21, and we have 21 participants. Awesome. Tonight's program is entitled Flip Clock Copal Motor Repair, and I specifically entitle it Copal Motor Repair because there are a number of things actually that are very unique about the motors that Copal, which is a Japanese company, actually built into these motors, and it makes them a little bit different than the average electric clock motor to repair. And we'll be talking in detail about what some of those are. It doesn't exclude other motors, so the information that is learned here may be applicable to other motors, but we thought we'd focus on these since they're very popular when it comes to what you run into in the world of flip clocks. And my observation for some time now is that these flip clocks have been very popular. So for example, in 2015, we saw a real interest in the RC6015, if I'm not mistaken. We talk about it a little bit later, which was the flip clock that was used in Back to the Future, and it shows up a couple times in that movie. All of a sudden, all these things disappear around 2015. But in general, we see these things being bought, sold, and traded all over the place. But the problem with them is, as you would imagine, most of these clocks that were built in the maybe late 60s, probably 70s, are now beginning to fail. And it's remarkable that they lasted as long as they did. But now they're starting to fail for a number of different reasons. So we'll talk about those reasons in this program. There aren't a lot of best practice repair tips published anywhere, which is part of the motivation for this presentation. So we're going to cover a lot of those issues, with the exception of replacement gear / wheel fabrication. And that will be a part 2 of this series that will come later, probably the second or third presentation in our series next year. So 2021, maybe February, March. So there's many examples of these. We're going to go through and talk about sites for collectors, how much skill development you have to do to be able to work on these motors, and all the other things that you need to do in order to achieve good results with them. As a background, we recently did a presentation called A Tale of Two Motors, and here's the reference for where to find that Vimeo presentation. And that presentation actually is why this presentation can be as short as it is, because we're going to refer to some of the methods and techniques that were described there. So you can view that presentation as well. That presentation covers 2 motors. One is the Hammond rotor, which isn't really necessary. That knowledge isn't really necessary to understand the discussions we're going to have in here, but then also talks about a general time motor. And that discussion is very much relevant to what we're going to talk about. So one thing, if you're really interested in flip clocks, is you ought to visit flipclockfans.com, and the link is provided. It was created by an enthusiast who absolutely loves flip clocks. His name is Mike, nicknamed Mackie Hensley. It has a great forum, much like we have a forum on the NAWCC board for asking questions. And if you wanted to research issues related to a clock you might have, or better understand a model or something, there's plenty of information there. He's got some repair tips, some resources. So a very interesting history on some models, including the early New Haven flip clocks, which are believed to be the earliest of the flip clocks. And he also provides access to a YouTube channel with all sorts of interesting tidbits about these clocks. They're very entertaining. Mike Mackey does a really good job of creating very entertaining videos to watch. So check it out if you get a chance, or as he says, check us out if you have time. So here's some examples of some famous flip clocks, both of which, in this case, both use the Copel motor. On the left, you see the infamous 6015 Back to the Future clock. And there on the bottom is a clip right out of the movie where you could see the infamous Pepsi Free sitting next to it. And on the right is the RC6025 Groundhog Day clock radio. And there you see Bill Murray sound asleep just as the clock flips over to 6 o'clock. And it sings "I Got You, Babe" for the, I don't know how many times it sings that as he goes through his little episodes. So those were those shows, those TV programs made these clocks infamous. Tonight we're going to be talking about a Copel 802 motor. This particular model is called the green light because it has a small green neon bar at the top that is visible at night. You can see it lighting up the numbers so you can tell what time it is. This is a fairly substantial size clock. I mean, it's probably close to 12 inches wide. It doesn't look it from this picture, but it's fairly large, very substantial, hangs on the wall. Very attractive clock. This particular clock was very well cared for. The customer loves it. And so, we wanted to go out of our way to make sure that we took care of this for him. And guess what? It came in with the same symptom that we talked about earlier. Plugged it in, the motor turned, but the numbers didn't budge. As far as skill level is concerned, don't make the repair of these motors your first experience in clock repair. You'll probably get real frustrated. You're going to have to know something about fabricating simple parts with relative precision, kind of the same precision you'd expect in any horological application. You need to understand safety. You need to basically cut the power supply wires and then resplice them, solder them properly, and insulate them properly. On the lathe, well, basically you're going to make parts for these things on the lathe, involving drilling and tapping pillars, bearings, new arbors, hubs, and things like that. So, and of course the use of the mill for doing gear cutting. Now, we did in our last program on bicrinous clocks talk about making gears out of phenolic material for basically the bicrinous clock. And that is largely relevant in this case to this as well. But there's going to be some differences, primarily in the mounting of the gears, that we'll talk about in part 2. Now, these were, as Mackie points out on his website, these motors were not designed to be repaired. But it doesn't mean we can't repair them. We just got to kind of learn some of the tricks. So they are actually repairable. They just weren't designed to be repaired. So let's talk about some of the places where stuff goes wrong on these. Well, right away, looking at this picture, the one that caused the failure in this case, and in the clock I showed you earlier during show and tell, was right here, this hub. And it happens to a lot of these clocks. There is a serrated shaft. This arbor is serrated, and it's forced at production, is shoved or forced, more like rammed onto this poor nylon hub, which creates a pretty substantial, force, outward force on it. And eventually, that plastic, it's going to flow a little bit, and it can only flow so far before it splits. And it's interesting because you see the same phenomenon in many typical quartz clocks, where the same method is used in manufacture. And actually, when you see a quartz clock fail, chances are it has nothing to do with the electronics. It's probably a nylon wheel with a serrated arbor that split. And if you can figure out a way to fix that, you can get your $5 movement running again, which is why most people don't try to repair those clocks, because they're just not economic. It doesn't make economic sense. The other problem you run into is the output shaft / bearing interface. They clog up. They get ground up particles stuck in there with oil that gets harder and harder over time, and from the heat of the motor, and sometimes from the heat of unaccompanied radio inside the same case, all adding heat to the thing and boiling out that oil or drying it out. And actually, that's one of the key issues with these things. that folks like to go in and try to get oil into the rotor, but they don't pay any attention to what's going on with the gearbox. And the gearbox actually ends up getting jammed up, and now the rotor runs and grinds up the rest of the movement, which is a big problem. So that's why if you're going to oil that rotor, you darn well better take that gearbox apart and take care of it too, because if you don't, you're going to have stripped gears. And that's probably the #1 reason why these gears strip, is because the motor keeps turning, the rotor keeps turning, grinding away at those gears, and the output shaft is locked up and can't move. In the case of this particular clock that we're going to talk about, this lower bearing was an absolute disaster. Both the arbor and the bearing had, it's an aluminum bearing, it's a hole in an aluminum sheet, had worn so far out that it actually had failed safe, if you will. The gear disengaged, and the upper bearing did not lock up. It looked like someone had serviced it previously, so it most likely had been lubricated at that time. So the other problem you have with these is other people try to work on them, and they do their best, but maybe they don't have the right equipment or whatever it is, and they end up causing issues. Now, in this case, the bushing was glued, which indicated to me that someone had trouble with that bearing at some point or another. So here's some examples of what we were just talking about. Now on the left, I took this picture out of a Flip Clock's YouTube, Flip Clock Fans YouTube. And I'm not exactly sure how that gear got warped and distorted like that. I cannot give you a reasonable failure analysis of that. I'll have to leave that one up to Mackie. But on the right, what happened here was more typical, which is the output shaft clogged up and put an incredible load on the gear train. That led to wear in the hub bushing. You can see here. You can see it's very large compared to that shaft. And yeah, because these are set up differently than most horological applications. The bushing is actually the entire length of the gear itself molded in. And the arbor is actually what this wheel rides on. It does not move with the wheel. So in this case, you can see the wear there. And as it wore away, trying to drive this locked up shaft, it began to disengage, and the pinion on the previous wheel just chewed up the teeth. And so you can see that there's no teeth left there. So that wheel would have to be refabricated because of that. So on the subject motor, here were the issues. You saw the output bearing glue, lower bearing wear. We had the split output hub we talked about. We had the worn out arbor / pivot, bent plates. And it's interesting, I noticed that these two plates are sandwiched together, which makes for a fairly rigid motor when all this is riveted or fastened together. It's kind of an interesting thing, but that's the list of issues. You can, once again, you can see the split here, and that's actually the thing that, and well, I mean, it was both, because this was free running, but at the same time, you know, the bearing was so worn out that there was virtually no engagement, which was why I say it failed safe. So if you're going to take one of these things apart, even though there's lots of pictures in here, there are differences between these motors. So take lots of pictures. If you don't, the wheel locations and orientation can get mixed up very easily. They're a little bit confusing because they got quite a few gears, and it's not, you know, routinely obvious how those go back together again. So take a picture for yourself before you take too far into the work you're going to do here. So you're going to have to get the pillars apart, much like we talk about when we do telecron rotors here on the right. We use, you know, the ring pliers to pop the plates apart at the pillars. And we go ahead and take the rest of the thing apart, and we'll show you how to do that here in a few minutes. Zenith 77 is the best cleaner for these because you got aluminum involved, and aluminum and ammoniated cleaner absolutely despise each other. So you don't want to marry those two together. And the other side of it is that you got a lot of aging plastic wheels, and I'm not exactly sure how ammonia is going to treat those worn nylon aged wheels. And then use a naphtha rinse to get everything dry and free of Zenith 77 when you're ready to take the parts out of your cleaning system. Okay, so here's my recommended method for taking these apart. You can try the ring pliers. About half the time, the ring pliers will work. The other half the time, you'll see the plates start to distort so badly, it'll be frightening and you'll want to do it. One thing you could do is put a small piece of brass, maybe a 16th inch thick piece of brass in there to kind of distribute the force a little bit better. And that might help get things to pop more readily, even if you have to cut a little groove or a little U into that piece of brass to work around that pillar. But one way that is absolutely sure to work is if you take a piece of 1/4 inch brass and mount it in your, in your vise, and you cut a small groove into that piece of, it's about 1 inch by 2 inches or so, seems to be a good size by 1/4. And you mount the pillar in between into that little groove, as you can see here in the picture, and then give it a light tap with a small punch from your staking set, or a small drift punch if you don't have a staking set. And in 1 or 2 very light taps, that pillar will be out. Remember, those are all those pillars are all aluminum, so it doesn't take much to drive them out of that plate at all, and it won't hurt the plate and it won't hurt the pillar either. So this is a great way to go about doing this. And in no time, you'll have not just the plates apart, but what you want to do is continue on and knock the pillar out of the other side too, so that you can get that free running plate out of there. We talked about the sandwich earlier, because often you're going to have to rebush or do something with it anyway. And you'll probably want to assemble this thing the way we're going to show you, which will involve by necessity turning and tapping those pillars. And that can only be done once the pillars are free and out of the movement. Well, I mean, you could probably do it without doing that, but it's not going to be anywhere near as easy. So the next thing you're going to do is we set up a little cut anvil here. We just took a piece of brass, cut off, drilled a hole in it, and found a block of steel. You can buy a block of steel, reasonable size, maybe 1 inch by 3 by 3 from Amazon if you want to. They're fairly readily available. And all you're doing here is giving yourself a little bit of weight in order to provide a reasonable backstop for the staking operation that's shown on the right. So you thread the quote unquote thread, the pinion into the hole here of this brass cutoff. You take a small pin punch and a hammer. And if you're not familiar with pin punches, it's Mile High 47.890 is the part, and it's a kit. Small punches that'll allow you to knock that, I think it's somewhere around 0.63 arbor. You want to knock the arbor out of the rotor and through to the bottom. Trying to pry the pinion side will be a disaster, so don't try that. Just knock it out from this side. It takes 2 or 3 taps and it's out. And then you got this. If you look on the bottom here, you have the motor itself with the windings in the field. You have the rotor and you have the arbor. And you also have a little washer here you have to be aware of. You might want to take a very close look because you don't want to lose those washers. You might call them thrust washers, but they do provide space that keeps the motor from getting noisy. So don't want to lose them. And again, don't pry the pinion off, please. That is the most damaging, potentially destructive thing you can do. Now, if you look at the older motors, back when we did our presentation on the Tale of Two Motors, we ran into quite a few 1930s to 1950 motors that, frankly, the lubrication was complete sludge and varnish. And there was nothing left of it. It would not soften no matter what you did to it. You added more lubricant. All it would do is loosen the solids, and then it would fall right back into the motor or the pinion and jam it up in no time at all. So it's real critical with those motors that you take the bearings out. You have to get those bearings out of there to get all that sludge out. Well, with these 1970 motors, you may not have to. The ones I've run across, the lubrication is still soft. And adding more lubricant to it actually works. It's not a terribly bad approach to it. But just be aware of it. If the lubricant, because it's in a clock radio that has, tubes in it or something, if that creates enough heat, it could harden the oil. So this whole thing about being able to lubricate without worrying about sludge only applies to some of the motors, but not all. But if you do have one that has no dried lube, then you can basically peg out the holes and apply new lubricant, and you're done with that aspect of it. And usually the arbors are show no wear. Now, on the other hand, of course, if your bearings are worn, then you need to refer back to our tale of two rotors, I'm sorry, tale of two motors, and go ahead and use the instructions that are shown in that presentation for removing those bearings and properly servicing them. Now, a little commentary here is not going to make me one of the great fans of the flip clock folks, but I got to tell you from a horologist perspective, this is very important information to share. If you look online, there's examples and videos of where folks are just squirting oil in around the rotor. And, you know, my opinion is that, yeah, that might work. But then you always have to ask yourself, where does the rest of that lubricant end up? Because you're blindly squirting oil, you don't know where it's going. Once that lubricant starts to harden, if it ends up in the wrong place, it's going to kill that motor dead. So that's a concern. But the bigger concern, honestly, isn't that. The bigger concern is that if that rotor needs lubrication, so does the gearbox. So you got to get that. You got to get into that gearbox, and you got to get a look at it. So in fact, loosening the rotor through oiling it might be the last straw for that motor, because if that output shaft is jammed up, there's a lot of gears in these things, and there's a lot of torque by the time you get to the second last wheel in the train. You're going to chew up that wheel and destroy your motor, and then it's going to be expensive and difficult to fix. So, and if you don't have the equipment to do it, you're going to have to send out, because it's not everybody that has gear making equipment in their shop. So the other thing that you run across online is folks recommending, well, if your motor's jammed up, then soak the whole motor in alcohol. Well, that's interesting. Maybe that'll get at, you know, the output shaft, maybe not. But the problem is that isopropyl alcohol is 9% water. How do we get that water out of there? If it gets into anything where there's steel, it's gonna potentially rust. Now, that's not the worst of it. The worst of it is that who knows how that alcohol is going to affect the winding insulation. And immersing the windings as part of the motor in alcohol may not be very good for safety either, because if you leave a dirt trail from eaten through insulation out to a metallic part of the motor, now you've created a safety hazard too. So this is not a good idea. It is not a good idea at all. And I've seen it at least 2 or 3 videos out there, and man, don't do it, folks. It's not a good thing. Now, I know, again, as I said, I know this is going to make me a very popular person because it involves now doing a little more disassembly and checking, but it'll give you new life to your motor if you do it the way we're describing here, or even if you just lubricate everything straight up without taking everything apart, if the motor is still serviceable. You know, at least it'll guarantee the motor runs for maybe another 5-10 years, who knows? So here's what we ran into with this particular motor. The bottom bearing here in this, double plate we showed earlier, the stacked sandwich, it was worn 2 times the original diameter, and it required rebushing. Now, there is no way I'm going to use an aluminum bush. Aluminum and steel don't like each other generally, which is why in these clocks, most of the bearings are between plastic and a steel shaft, except here, where there's the most torque in the entire motor. So not sure why that made sense to the folks who design these things, but that's the way they are. So what we're going to do is we're going to create a bronze bushing with a little extra height, and we're going to create a new output arbor, since the arbor here, as you'll see in a few minutes, was pretty darn worn out. And we're going to put all that together in addition to creating a new hub for this output wheel, which was, as you saw, split open. So the most important part of this project is fixturing this lower plate so we can locate the original spot where that hole started. It's not trivial to do that. There's no way you can do it by eye, not when they're worn out 2X. So we mounted this in the 4-jaw Shoreline chuck onto a Shoreline mill. As you can see here, it's locked all together. Then we used a 40 thousandths 1mm drill blank. You could actually turn a drill around backwards and do this too, get the 40 thousandths I guess that's what, a number 60 drill out of your kit, and turn it around upside down. You could use that if you don't happen to have 40 thousandths drill blank. And you use that to spot the location of where this hole is supposed to be. And it's a lot easier to do than it is to describe. But you'll put that 40,000 drill blank in the mill chuck, and you'll move the XY until it exactly falls where that original spot was. And then once you've got that set, you take, I guess this is a medium centering bit. Realistically, you could probably use an 093 if you wanted to, an 093 spotting drill, and cut through, and it just makes a little bigger bushing. But since you know exactly where you are, you don't have to worry about the size. In this case, we use an 080. It cleared the wear. And it's always important when you're cutting aluminum to use a product like AlumaCut. If you have a preferred aluminum cutting oil, that's great. Regular oil doesn't work very well with aluminum like it does with brass and steel. You have to have something that's formulated for aluminum, and AlumaCut's a really good product for that. Here's us, we're turning up the bronze bushing here out of 544 bronze. I show you the dimensions here if you want to refer back to it, but here's the 080 that corresponds to the hole we just drilled. The OD on the bushing is 125. The depth of this part of this shoulder part of this bushing is the plate thickness plus 10 thousandths, since we're going to rivet. And then the bushing OD, the bushing size here, the width of the active part of the bushing, that depends upon the rest of the movement dimensions. So it's hard for me to dictate that, but you get the idea from looking at this. I believe this was, it turned out to be a millimeter in the case of this particular motor. Here's our output arbor, pretty worn out. You could see what's left of the pivot there. And here's the serration we've talked about earlier that causes the split on those plastic hubs. Now, this is funny because this actually measures, the majority of this arbor measures 71, but in this area it measures about 78. So that's a fair amount to stress that nylon hub. So here's the dimensions of the part in this case, and you can refer back if you need to. You can buy this 072 material, 1 mil bigger, so it gives you a little play. You broach some things open to get them to fit, but it's not a lot of work when it's only a mil bigger. This is a number 49 drill rod. It's annealed, so it can be easily turned into an arbor. And here's the dimensions of the replacement arbor that you can use as a reference if you need to. And the other thing we needed to do, remember, was we needed to make a new output wheel hub. This part was originally nylon, this white section here on the left, and it is what split. And it was split because an 076 was driven through probably an 072 hole, and that caused a ton of stress on that nylon, which over time caused it to split. So what we're going to do is we're going to make this output hub by turning a piece of 1/8 inch brass so it has a small step in it at the end, you know, kind of like a shoulder. And we're going to put an 093 OD on that. And then we're going to make a bushing. That's 156 OD, 062 thick. And we're going to drive that. We're going to size that hole so it fits tight onto that end. Here's our wheel. This is the nylon wheel. We've cut the hub off and sanded both sides flat and opened the hole with a broach until it's just slightly under 093 and fits tight here. We could put a little bit of cyanoacrylate on here, or if you're not comfortable with how fast you think it'll take you to put this together, and then use a little bit of epoxy. And then we're going to drive this bush on there. And actually, the bush alone will hold it tight, but it's nice to have the glue there just as a backup. Make sure everything's clean. You know, it's good to rinse everything very thoroughly, especially the old nylon wheel that might have oil on it from years of being inside of a movement. So, and that's pretty much it. Get this thing together before the glue sets so that everything runs true. And that's how we replace our, and then our arbor goes through the center of this. Once we're done, you might have to broach it open a little bit on both sides to get it to go, but that's how we make the replacement hub that we then use for that output shaft / output wheel assembly. And then we get our pillars, which we took out earlier. We clean up the shoulder section of it so it'll fit back, so it's a clearance into the holes in the plates, because as it was riveted, so it's going to be a little oversized. You want to get that off of there. And then you're going to center drill. Oh, the other thing you want to do is shorten it so it's the total length of that shoulder comes in just under the thickness of the plates that you're trying to clear, so that when you screw this thing together, it tightens it and holds it solid. So we're going to use an M1.6 by 0.35 millimeter thread when we get to this point, and you basically can drill with a number 55 drill, and it gives you the right size for an M1.6 thread / tap. And then here's the part numbers for the screws if you have trouble finding them. Time Savers makes it, and so does McMaster Car supplies it. And you can go there and get those. You can see the screw fitting the tapped thread there. And, you know, it's a really good idea to clean out all that swarf with naphtha and blow it out if you can, because it's going to be full of lots of little aluminum pieces that don't go well with steel. And here in the background, you see the AlumiCut that we used when drilling or tapping. It's absolutely essential. If you don't use that, you will destroy the threads as you're cutting them. And here's when everything's all done, you can see everything reassembled here. And you can see the screws now. The beauty of this is reassembly is a piece of cake, as is disassembly. So in the future, if anything more needs to be done with this motor, it is now serviceable. And here's how things stack up. You can see all of our parts. We can see the little bronze bushing we made here. You can see the little hub here with the retainer bush back here that holds the wheel, the nylon wheel in there nice and tight. You can see the arbor, and everything goes together and geometrically and dimensionally works just like it should. As far as lubrication is concerned, my recommendation is to use Super Lube, this multi-purpose synthetic with they call it Syncolon, it's Teflon. Use this for everything. It seems to be fine. And it's just the right amount of viscosity. And this is one of the slipperiest lubes that I know of. You know, it's great stuff, and it's easy to apply. So reassembling the clock, a couple things we didn't talk about yet. One of the things is that all these motors come with one of these plastic housings. And I will 100% guarantee that you will not get that off without cracking it. Because what they do is they turn in the edges by these slots. I'm not sure how they do it or how they did it. It might have been treated with heat when it was assembled to turn that in, and you cannot get it out without it cracking. I've tried heating them, they crack. I tried not heating them, they crack. The problem is the plastic is just that old, and it's starting to get really brittle. I'm sure when it was new, it could have been done, but once the plastic gets old, it starts to get brittle. So, I mean, even though it's broken, it's still better than nothing. You could actually use Kapton tape, 1/2 inch, 2 mil thick Kapton tape, and run it clear around the motor or around the housing. You can't cover this slot because the wires go in and out of there. But everything else you could cover with Krylon tape, and it'll give you a reasonably good cover and give you a little more life out of your little broken lid there. Reattaching the wires, as we said, you want to butt solder those together and then shrink tube over them. And unfortunately, the picture didn't come out as well as I'd hoped, but you can see the shrink tube there. And they do cross over. I did not connect the red to the purple, or white to purple and purple to white. It actually was connected correctly, but they crossed over going through this little retainer here. So, and then you want to go ahead. In this case, what I did was I test ran it before putting the cover on. And it's only 2 nuts that hold the motor into the clock. So it's easy to take in and take out if you should have to do any adjustments once you test run it. That's pretty much it. That's our program in terms of how to deal with these motor issues. I'm happy to take any questions if anyone has any.
So Ken, did you have to rebuild any of the wheels, like with the other clock in the last presentation?
Not on this one, but they do periodically have to be repaired, and that's what we're going to cover in part 2. You know, the trick with these is Cutting the wheels is the same as what we talked about in the previous presentation on the Vicronus Hammonds. But the difference here is the way you mount the wheel once it's cut. These are very small wheels. I mean, the OD on these things they're under a ½ inch. So how we go about cutting them is a little bit different. You don't cut blanks like we talked about earlier. You're going to take a bar of the appropriate plastic and cut a length of of basically, tooth to bar. By the time you're done with it, you're going to have a bar with teeth on it. And then you're going to part off those individual teeth to the width you need. And then the real fun starts. And that is mounting it getting it into the movement, getting it into the rest of the assembly. So we'll talk about examples of how to do that in the next presentation. And, for that matter, how to get the old wheel out of there. There's a couple of interesting tricks. I'll give you a preview. One of the tricks is you can even make some of these wheels out of brass. I mean, there's no reason they have to be plastic necessarily. A couple of them that are the closest to the shaft coming off the motor, those probably want to be plastic just for the sake of keeping the mesh, the gearing sound quiet. And once you get away from that, you can make them out of whatever material you want. And there's actually a method that works very well, which involves, making the wheel and then cutting it out as a rim and then fitting it to the old wheel. And some trick machining there is not hard to do. You can actually lay a new wheel over the old wheel. And, unless you knew it was there, you'd look at it and go, yeah, it looks like a normal wheel. So we'll talk about some of those methods in part 2.
Dave Cooper says you could use kerosene as an aluminum lubricant for machining. That's a good tip.
Well, thank you, David. It's good to know. It's probably a little more available than Lumicut to most people. Will naphtha work? Maybe you never tried it. Naphtha or paint thinner, I guess you can buy kerosene at the local Home Depot too.
I've never tried naphtha. But can you hear me okay?
Yes, great, thank you.
Yeah, I used to work as a machinist and we used to do a lot of work in aluminum. And kerosene works quite well with that. It's, as far as I can see, virtually identical to the lubricants that you buy in a can. But that being said, there's a lot of different types of aluminum.
True. And
aluminum can be very gooey, so you have to machine it at very high speeds with sharp tools. If you're buying aluminum or rod stock, excuse me, what you want is 5051 free machining aluminum, because there's other stuff that some of these aluminums that are used in different products that come out is real junk for machining. It just is almost impossible, but you have to have a really sharp cutting tool. You have to run at a high speed. And so machining aluminum can be pretty problematic depending on what type of aluminum you're using.
Yeah, machining these pillars was a little gummier than I would have liked to have seen.
Yeah, and that's the aluminum. If you buy aluminum, you want to buy 5051 free machining aluminum rod stock, and that stuff will just machine up very nicely.
Yeah, it's a great tip. Thanks. Thank you.
Yeah, 6061 T6 aircraft aluminum also is fairly easy to machine.
The other thing for nylon there too is you can use Delrin and some of these other free machining nylons if you have to make some of this stuff.
Yeah, Delrin's much preferred over nylon for machinability.
And actually, when you talk about replacing a wheel rim, I've had occasion a couple of times, depending on the watch it's made, sometimes you can do that redoing a watch barrel. Depends on how thick the barrel is, but I've done it a couple of times. Is machine the ring and put it on and replace the damaged, tooth section of the barrel.
You presumably solder in place, right?
I guess you can. You can do a press fit, and I hate to say it, but cyanoacrylate will hold stuff on really, really well. But soldering is another choice. Press fit is one.
You also have anaerobic too, if you don't trust your press fit.
Yeah. I think press fits, you've got to be really careful. You don't want to have any taper there because you can get the thing halfway on and then you can't get it on the rest of the way. So if I have room when I'm doing a press fit, I'll machine it to a press fit size. And then at the root of where the wheel is going to lie, I'll machine it back a little and leave a little bit of clearance there. So once you get your press fit halfway on, it'll go on the rest of the way, and you know it will go on and it won't break the part you're pressing on.
Yeah, it won't split the rim, which is that's a trick. You got to get the rim the right thickness in order to avoid problems. I mean, back in the day, we used to do this with escape wheels, so we didn't have to do the crossing out aspect, and you could then finish it up with paper, and you'd never know it was there.
Yeah.
Yeah, I've kind of moved away from that, but I did a few that way over the years. But we're not going to be able to solder in the case here but we may be able to use glues because, we don't have a lot of force in these motors. That's the good news. So glues are an option in this case to hold that rim in place.
It's like anything. You've got to use it in the purpose for which it's intended. And that's where people get into trouble with this stuff. It's not the glue or other fasteners, it's they don't use them in the proper method for what they're using them for.
Right. Yep. That's
The
good.
thing I like about cyanoacrylate or super glue is that, of course, you can just soak it in acetone anytime you want, and the whole thing comes apart again, and you can do it all over again.
Yep. It's a little bit like shellac.
Yeah.
A little harder, a little tougher to dissolve, but it'll get there. In that sense, it's kind of reversible, I guess. Anyone else have any questions?
Thank you, Ken. Very interesting.
Well, thank you guys for hanging out for 45 minutes or so. I hope you find it useful down the road somewhere. All right. Okay, well, this concludes both our meeting and our program for the night. And again, I want to thank anyone that has attended, folks within Chapter 21 or guests from outside. And we appreciate your being here, and you're welcome back anytime.
Thanks, Ken.
Thanks, Scott.
Thanks, Ken.
Thank you very much.
Nice presentation.
Thanks, Ken.
Thank you.
Yeah, good job.
Thank you.
All right. Thank you. Good night, everyone.
Good night.
Good night.
Night.